So today I'm going to look at the problem number of steps to reduce a number to 0. This is a pretty straightforward problem, but the time complexity could be a little bit complicated. Okay. Given a non-negative integer num, return the number of steps to reduce it to 0. If the current number is even, you have to divide it by 2. Otherwise, you have to subtract 1 from it. And down here we have example of number 14, example of 8, example of 123. And the constraint is the input has to be from 0 to 10 to the power of 6. Let's say if the interviewer would just give you a problem to calculate the number of steps to reduce a number to 0. What do you have to do? First, you have to ask clarifying questions. So what is our input? Is it an integer? Let's say it's an integer. So in questions, input of type integer and output is also the number of steps is also of type integer. So we got the input and output clear. Are there any constraints on how to reduce? How should I reduce the input to 0? So the interviewer then could give an answer like, oh, if it's an odd number, you have to subtract the number to 1, and if it's an even number, you have to divide that number to 2. Can this input be negative? And no, it's just a positive integer, just positive integer. Right, so can this input be 0? If this input be 0, if this input is 0, I can just return 0, right? So that's easy. Another great question we can ask is, can I modify the input? So in this case, let's say, yes, I can modify the input. So if something goes wrong with the system and we want to retrieve the original input, we cannot retrieve it if we have modified the input. So it's probably safer to just create a new input anyway, because it's just an integer. It doesn't take up a lot of space. And so a straightforward solution is to update the inputs or create a new variables that has the same value as input and update that integer depending on whether that integer is odd or even until it reaches 0. And we can have a while loop, and that while loop will just keep reducing the numbers, and as it's reduced the number, we would update the steps that needed to reduce the number and then return that step variable at the end. That sounds like a pretty reasonable solutions, and it shouldn't take more than big O of n time. In this cases, even number, we would have 4 divided by 2 to equal to 2, and 2 divided by 2 equal to 1, and then 1 divided by 1 is an odd number, so it's 1 minus 1 is 0. So let's cut this up. So at first we initialize a new integer value equal to num, and then we also initialize a variable step of type integer to be 0, which is the result we're gonna return later. Return step. And then create a while loop. Y num is not equal to, so we update the value. So y value is not equal to 0. We update the step, and then if value mod 2, if value is an odd value is a if value is an even number, we would update the value to be half of the current value, and if it's an odd number, we would subtract the current value by 1. Let's test this code. So for this test case, number we input number 4 into the code, right? So value would be 4, and then we update the value. Value 4 is not 0, step now be updated to 1, and then 4 is an even number, so we update the value to be 2, and step 2 is not 0 yet, so step will be updated to 2, and then 2 is also an even number, so value will be updated to 1. 1 is not 0, so we update step to 3, and 3 is an odd number now, so we would decrease value to 0, and the result would be 3. So this should work. And if step is 0, the while loop will not be executed. Sorry, if value is 0, the while loop is not executed, so the result would be 0 afterwards. Let's try to run this code. I accepted. Let's look at the time complexity of this piece of code. If we have the integer num as input, how many times num have to be updated in order to reach 0? So how many times it would divide itself by 2, and how many times it would subtract itself by 1. So every time we have an odd number, this odd number would be subtract by 1, and so the next iteration we will get an even number, and then this even number will divide itself into half. And then the question is, what do we get after the even number divided itself into half? We could get an odd number or an even number, right? And if we get an odd number, the next iteration would become even. So let's just say that we would just get an odd number every time, which is a worst case scenario because it's gonna take an additional numbers to become even. If we divided even into half, even divided itself into half would be smaller than this even, if you know what I mean, right? So odd minus 1 divided into half would be smaller than odd divided minus 1. So odd minus 1 is this even. And then odd minus 1 divided by 2 is this even, right? And so in worst case scenario, we would get odd every time we divide it by even by 2. So let's just say odd, we would get odd and then even, and then we would get odd, and then we would get even. We would alternate between these two values, and we could see that odd or even is pretty, the number of odd value would not be more than the number of even value because we get even right after we get odd. And so the worst case scenario, we would have the same number of odd operation as the same number of even operation. So this operation would be the same, and we would have the total operation to be number of odd plus number of even. And if we divide this by n, we would get 2n, and the big O runtime would be 2n because the big O runtime would be n because we ignore the constant 2. Now, let's apply it to this step. So we just care about the even number divided by 2, right? So let's say we have n as a start num, and then for every step n has to be to divide itself by 2, and divided by 4, and divided by 8, until n divided by itself to be equal 1, right? And then the next step would be 1 minus 1 to be 0. So this is like the odd operation that we were talking about, but we just care about the even operation for now. We would quickly observe that the denominator is the exponents of 2. So we have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of what number would get us n? And this question mark would tell us how many numbers are there in this series, and which tell us that how many times the while loop operates in order to reach 0. So 2 to the power of question mark equal 1. And this is basically a log operation. Question mark would equal to log base 2 of n. And in big O notation, we don't care about the base either. And so the runtime complexity would equal big O of log n. There you have it. Big O of log n. And space complexity, in this case, could be big O of 1, because we only use integer variable which does not depends on the input num. Hope that helps.